Hi, my name is Kelly, and I'll be introducing our project. My team is the Super Smart Snack Solvers, and our project was encouraging tool use for great apes for the female orangutans at the Henry Vilas Zoo. This is our problem statement. Our client was Elise Scorchels from the Henry Vilas Zoo, and our project was to design an appropriate tool that prolongs feeding and encourages mental stimulation.
Hi, this is Drew, and I'll be going over the product design specifications for our project. We had a $300 budget, and there were safety specifications that are put in place to ensure that there is no danger to the animals and that the product won't break in the enclosure. And our first design was the Pokeball Extreme, which is a contraption that when you push a button, it splits into two halves of different enrichment feeding devices.
My name is Henry, and I'll be introducing our second and third design. Our second design, the Gravity Grubber, is a large see-through cylinder where the great apes would have to manipulate obstacles to get food to fall from one level to another. And then our third design is the Kiniak Combo, which is a series of PVC cylinders that hang from a chain with food compartments that the great apes will need to manipulate to receive their food.
Hi, my name is Sarah, and for our criteria, we have enrichment level, durability, versatility, maintenance, and safety and cost. And while scoring them, we found out that the Kiniak Combo will have the highest score in all of the criteria, so therefore we will be going on with the Kiniak Combo as our final prototype.
Hi, my name is Jack, and I will be taking over for the fabrication part of the project. To start, we had to cut segments of thick green PVC for the outside of the tubes and small white PVC for the inside feeders of the tubes. Additionally, we had to drill holes into the PVC for apes to get the food out of. From there, we drilled holes into the white end caps and then used a hacksaw to cut the segments out in order to make the rotating end caps of our project. Next, we used a laser cutter to cut the rotating inner pieces of the object, the little covers. We had to sand the white PVC inner tubes to make them fit, in addition to the covers. We also had to drill little screws into these so that we were able to make them rotate on the inside. Following this, we had to heat up the ends of the PVC so that the PVC end caps could fit, and we had to cut the fire hose for in between the PVC and our final project. From there, we moved into testing where we pulled at the insides to make sure those wouldn't be able to be pulled out, and we stood on it to make sure it would withstand the strength of an orangutan, among other tests for strength in a pass-fail measure.
I have all the things so
Once this was done, we epoxied the metal to make sure that there would be none exposed. We fed the chain and fire hose through, and we were done with our project.
So I'm going to demonstrate how the machine is used. Basically, food will be placed in these two holes right here. This sliding hinge here will allow the animal to reach in and grab the food inside. And then we have a sliding cap here that has a hole in the middle here, like there, where the orangutan will have to tilt the machine to get the food out of this hole here. This stimulates them. They have to figure out how to rotate it, as well as these hinges. They have to keep open while getting the food inside.